Welcome to Beginner C++ Programming. In this class, we will introduce you to the basics of C++ programming, briefly discussing what it is, why you would use it, and what tools you can use for the learning process before diving into the details of the language. We will cover the foundations of the language, working with example programs to demonstrate the syntax used to create working programs, as well as the individual statements that make it all go. As always, if there is something you would like the library to cover in the future, don't hesitate to let us know. And with that, let's begin. So what is C++? It continues to be one of the world's most popular programming languages, coming in third after Java and Python. It was developed from the C language, hence the name C++, since putting a plus after a variable in C adds 1 to it. C++ continues to be used for a variety of applications, including video games, device drivers, web browsers, servers, and operating systems. This comprises a huge segment of the programming jobs out there, but more than that, C++ is a strong fundamental language, meaning that people who have learned to use it are often able to transition easily to other languages since the principles are typically very similar. For that reason, C++ is commonly used for education and teaching programming concepts. It is also worth noting that C++ programs can be expected to have better performance than C# or Java, meaning that they will run faster than a program written to perform the same task in that language. So how do we create these C++ programs? If you're looking to create working C++ programs, there are two steps. Number one, writing the code itself, and number two, using a compiler to convert that code to a working program. For writing your code, while you can use any text editor, even something as simple as Notepad, to write your C++ program, it is generally recommended to use an editor designed for the job. These tools, known as IDEs or Integrated Development Environments, help to recognize errors, provide shortcuts, and more easily connect multiple files. Common IDEs include MS Visual Studio, used typically with Windows, Xcode for Mac, and Eclipse, which runs on both, though there are many more out there, both free and for purchase. All of those are available for free downloads, but Xcode requires payment after 30 days trial, and Visual Studio and Eclipse both have more robust versions available for a fee. That brings us to creating the executable program. The reason you need a compiler to take your C++ code and make it something that functions is because computers by themselves don't know what to do with the file that you have written. The compiler takes that code and converts it to a language the computer understands and is able to respond to. Typically, we will compile our programs many times, testing them incrementally along the way. This is frequently where we find errors in our code or are able to determine whether the program is functioning as intended. For this reason, we want to make the process as quick and as easy as possible. There are many ways to compile our C++ programs. One that has been around for a long time is to download a compiler and, after installing it, use that tool on your files. A popular example of this product is GNU's GCC compiler. While this is how I learned, and is still a reliable choice, it is not what I would recommend. The learning curve getting started with it is steep enough to discourage new programmers, and practically speaking, most people who end up writing code professionally will be much more likely to use an IDE like MS Visual Studio. As I just implied, installing an IDE like Visual Studio is a much more common choice and offers features that you would not be able to use just working with the basic compiler. Using Visual Studio, you can learn to build projects with multiple files involved and to use their automation and shortcut tools to save programming time. For those who have a continued interest in programming, I would recommend considering different development environments and finding one that works for you. However, the purpose of today's class is to learn the basics of the language, and for that reason, we are going to take a shortcut out of working with a sandbox. A sandbox is a working environment ideal for testing before actually implementing the changes. We use the term sandbox and work with variations on the idea of doing website development, network design, server configuration, and more. In today's class, we'll be using a website design for testing and learning the C++ code. This website, https://cpp.sh, is a handy tool for working with C++ code. Before we get into a line-by-line analysis of the code itself, let's take a look at the working environment. Across the title bar, you might notice on the right-hand side it says Online C++ Compiler, making it clear the purpose of this serves. Essentially, it is working like a downloadable compiler, but with a lot less setup overhead required. For those interested in more technical behind-the-scenes information on how this works, there is an About link underneath that. The bulk of the web page is filled with a blank working space where you can enter in your code. Notice the line numbers on the left-hand side for easy reference. These don't affect the functioning of the code, unlike old systems that required you to number each line. They are just a debugging tool that helps you find your errors. Underneath the coding area, you see on the left-hand side a link to this code button. This allows you to send a link that not only takes someone to this page, but also takes them to exactly the code that you have written. This can also be a handy tool to use yourself to save a quick way to get back to your work later on. You could copy that link and send it to yourself in an email or messaging system, and then follow it whenever you wanted to begin your work again. To the right underneath the code, you see the Run button. This, of course, executes the code and shows you the results. While it is working, you will have an indication on the screen that it is running, and at the bottom of the screen, the Execution tab will display the results of your program. In addition to the Execution tab at the bottom, we also have Options and Compilation. These go a bit beyond the scope of today's class, though I will note that the Options tab allows you to pick the version of C++ you prefer to use. Since C++ 23 is still in development, I would recommend you leave it at C++ 20 for the time being. Now let's start the fun part and write some code. For this first example, I included a typo so we could identify an error and see how the compiler reacts. Let's go through this program line by line. Feel free to pause the video at any time and use https://cpp.sh to test these programs on your own. Starting at the top, we see #include IOStream. This tells C++ how to recognize input and output functions so we can display data and input values. Next, we define our function int main open and close parentheses. The int refers to the value, an integer, that this function will be returning. Every function takes in arguments and returns a value. In many cases, the functions don't actually receive any arguments. We call these empty functions, and you can recognize those by the empty parentheses after the name. Speaking of the name, that is something we decided on our own. There are include files that have pre-named functions, but when we are writing our own code, we simply make one up, though it is typical for our starting function to be main. The curly brackets after the function name plus parentheses contain all the contents of the function. It's a good idea to type the beginning and ending ones right after creating the function, then fill in the contents between them. Our first statement within those brackets is std:" cout. The std refers to the standard namespace features. We'll learn more about that later, and the cout indicates an output. Note the less than signs indicating what will be displayed, followed by the string contained in quotes. Also note that every statement ends with a semicolon. Instead of the string of text contained in the quotes, you can also have a variable name. We'll learn more about that in just a moment. Finally, we have the return 0 statement. This is returning the integer that was promised when we created the function. There is an error in this line because we missed the semicolon at the end of it. Note the compilation information at the bottom of the screen indicating an expected semicolon. Once you correct this and then run the program, you will have the traditional first program that people write. The return 0 doesn't actually provide any functionality for it, it just makes the function work as expected, returning an integer value. Now let's talk about variables. If you want to do much with your programs, you need to use what are called variables. A variable is a location that you assign a name and type of data to. There are a number of foundational data types. The basic ones that you should know right away are listed here. Int is used for whole numbers, double for numbers containing decimal places. Bool is used for true-false values, and char for any single character, number, letter, special character, whatever, that you want to assign to a variable. In addition to variables, we also have what are called constants. They are, strange as it might sound, variables that can't change. So if you need to declare a value to use across your program, but you don't want to run the risk of it being changed accidentally, you can apply the const prefix to the variable declaration. For example, if I wanted to create a number value with decimal places that could not be changed, I could do const space double space pi equals 3.14 semicolon. Let's take a look at a couple examples here. In the first example in the upper left, I created an integer named file size and assigned it a value of 100. Note there are three things happening in that one statement. I'm declaring the type of value my variable will have, an integer. I'm giving it a meaningful name, file size, and I'm assigning it the value of 100. By the way, you always want to assign a value to variables even though you don't technically have to when you create them. Otherwise, they will have a randomly assigned variable that can be very confusing to your results if you don't correct it at some point. In the next line, I am outputting the value of file size and at the bottom you can see the execution displayed 100. Not the most interesting program, I'll grant you, but it worked. In the example to the lower right, I declared a few different variables. Notice how I can create multiple variables of the same type in one line, separating them with commas and not ending the statement with a semicolon until the last variable has been declared. Then also notice the double variable is the only one with decimal places. Now let's do a common learning exercise for beginning programmers. Our goal here is to swap the value of two variables. This may be a little trickier than you'd imagine since we actually need to create a third variable to contain one of the values as we swap them. Starting at the top, you see we created an int named starting1 and assigned it the value of 1. Then we did the same thing for an int named starting2 and assigned it the value of 2. I then declared an int named swapValue and gave it the value 0, though that number doesn't really matter for our exercise here. At this point, in the next statement, I assigned swapValue to equal starting1, changing its value to 1. Then I assigned starting1 to equal starting2, changing its value to 2. Finally, I told starting2 to equal swapValue, and you can see how I took the initial value, moved it through the temporary location of swapValue, and got it to starting2. After all that, I used the two display lines to show the final value of starting1 and test my function to make sure that it worked properly. If everything worked properly, you should see the results below. Other than creating a tongue twister for me, what's the point of this exercise? Well, very often when programming, you're going to acquire or receive a value from a function or something else that you are running with, and you will need a place to temporarily hold this value before you can use it with something else. So working through these swaps and temporary variables is an important skill that you're going to want to learn. Now that we're getting more comfortable with variables, let's learn about the mathematical expressions we can use on them. As you see listed here, the standard expressions apply: the plus symbol for addition, the dash for subtraction, the asterisk for multiplication, and the forward slash for division. However, we have a few you may not be familiar with. You can also use the percentage sign as the modulus operator, which calculates the remainder of an equation. For example, 10 modulus 3 would result in 1, because the remainder when 10 is divided by 3 is 1. And we have the increment operator and the decrement operator, one adding 1 to the value of a variable or subtracting 1 to the value of a variable. I note here that you need to be careful of variable types. If you perform calculations on ints that result in decimal numbers, you may not get the results you expect, and mixing variable types in your calculations can cause problems. I also make note of the order of operators. Remember, multiplication and division take precedence over addition and subtraction, though you can override that with parentheses. If you look at the example on the right, you can see I created two variables, radius and area, and one constant, pi, then used mathematical operators, specifically multiplication, to calculate the area of my circle and display it. Let's dig a little deeper into writing output to and reading input from the console, starting with writing to it. We've already used them several times, but to review, std::cout is an object that represents the standard output stream. Less than is the stream insertion operator, and quotes contain a string. One big time saver we should usually incorporate is to add the line using namespace std semicolon to the top of our programs. That simplifies our code by letting the compiler know that we are using the standard commands, so you can drop the std::, before the outputs and inputs. In this example, I'm combining what we've learned about mathematical operators with some more elaborate output commands. You can see on the right that I am taking a base value of sales, performing some calculations on it, and making one long cout statement. A few details to note. Critically, I included the line using namespace std right at the top, so that I wouldn't have to use the std::, again and again. The organization of the cout lines has a couple things I want to point out. First, the use of white space. Using spaces and tabs, I attempted to make it as readable as possible, even though C++ doesn't really care about white space beyond the presence of the first space. What I mean by that is once it sees a space in its commands, if it's not inside of quotes, it just treats that as one space no matter how many you put in there. So you can put lots of spaces between objects, you can put tabs or blank lines in between, it doesn't care, it just reads it as one space. So we can use that to make things line up nicely and appear however makes it easiest for us to read. I also use the endl command to make the output behave as if I typed the enter key on a word processor, jumping to the next line. It's important to not put in any extra semicolons. There's only one for the cout statement because it is all one big statement even though it goes across multiple lines. Finally, I'd like to note that with this and every program, you can test them incrementally. What I mean by this is you could add one bit at a time to your output and watch how it changes to get a feel for what you are creating. Now let's talk about taking input from the user. The cin command is the opposite of the cout command, waiting for data to be entered rather than displaying it. It's important to remember that you must declare the variable in your code before inputting data to it. You can also chain together multiple cin commands like we just did with cout. The greater than symbol is the stream extractor operator used to indicate variables that will be receiving value from the inputs. Let's take a look at a couple of input-output examples. In the program on the left, you can see that I began with the usual starting values of the IO stream and the namespace. Then in my main function, I create an int named value and I request input from the console. Whatever number is typed in, the program multiplies by itself in line 7, and line 8 outputs the results. In the example on the right, I begin the same way, but this time I create two double variables. I then output a specific request for the low and high temperatures in Celsius. Apologies for the misspelling. Line 8 takes in both those values with one CN statement. Once I've received those values, I use division and addition to calculate the value of both in Fahrenheit, then line 11 outputs my results, which you can see below. It's important to know that there are a lot more things you can include beyond the basic IO stream. One popular choice is CMath. The reason to include this or any file is to add a number of recognizable functions to your C++ programming. In this case, you are adding a large number of basic and advanced math functions. For more details, you can find many references via Google. One that I'd recommend is https://cplus.com/reference/cmath. In it, you will get a comprehensive listing of the functions provided with extensive examples of their use. Once you've included this file, you can call the functions within your own created function to perform their task. Some functions, as we will see in our example, require multiple arguments, others require only one, depending on the nature of their task. Let's take a look at an example of using CMath. In this program, I use the hypot function to calculate the hypotenuse of a right triangle. I use the cin statement to acquire values for the first two legs of the triangle, then the hypot function gave me the answer, which I displayed using cout. Notice I put the arguments, leg 1 and leg 2, into the function hypot, and I received an answer without ever actually knowing how the function works. That's the value of these includes, is that it does a lot of things automatically for you. Before we finish with loops, I want to take a moment to discuss comments. Comments are information that you add to code for clarification. Importantly, comments are not compiled, which means they have no effect on the functioning of your program, but they can make a big difference in readability. There are two different ways to create comments in C++. The first is to use double forward slashes, which makes everything that comes after it in that line a comment, typically written above the line of code in question, but sometimes to the right of it. For multi-line comments, you can use the forward slash asterisk, then everything is a comment until the compiler reads asterisk forward slash. Try to avoid over-commenting your code, as it can become cluttered, and often the code itself should simply be clear in the way that it's written. Just add the comments when they're needed for more complex code. Finally, I'd like to discuss loops. Becoming comfortable working with loops is an important step in programming, so I'd encourage practicing extensively with these. The purpose of a loop is to repeat a task multiple times or until a condition is met. The flexibility that they provide is they don't necessarily need to be a set number of repetitions, allowing your programs to respond to different inputs in different situations. The basic components of loops are initialization, this is creating the variable that will control the loop, condition, which is the test that will end the loop, and an update that allows for progress or change. Mistakes in the update or the condition will make the loop run forever, breaking your program. This is nothing to be alarmed about, just something to be aware of when testing your program to figure out why expected results aren't happening. Common loop types are the for, while, and do-while loops. The for loop is good when you know how many times you want the task to be done, since it contains the incremental increase within its own structure. While and do-while loops are better for indefinite loops. The difference between a while loop and a do-while loop is a do-while loop runs once before ever testing the condition, so it's guaranteed to run at least once, while the while loop tests the condition first, so it may never run at all. Here we have examples of a for loop and a while loop. On the left, you see a simple for loop. I've created an int display value that will show a cubed value of I as I increases one at a time for as long as it is less than 10. Once I equals 10 or more, the loop stops. You can see the results below. So if it's unclear to you what happened, if we look line by line, underneath the declaration of the function main, I've created int display value and set it at 0. I also have an int inside of the for loop named I set to 0 that will continue the loop while it is less than 10 and will increase 1 every time through the loop. Every time through the loop, display value equals I cubed. And then cout shows the display value. So the first time through, we get a 0. So that's 0 times 0 times 0. Then 1 times 1 times 1. Then 2 times 2 times 2. And then so on until, as it loops around again, and I equals 10, the loop breaks because it is no longer less than 10. And then we return 0, and our program is done. That is predictable because we have the set value in this incrementing that is eventually going to hit that. On the right, we have a while loop. For this loop, I'm having the user guess a number between 1 and 10. As long as they don't get the right value, which is an int named answer that I created above the loop, it will continue asking. Note that the test for not equal is exclamation point equal. The test for equal is double equal sign, because if you had simply one equal sign, that would change the value that's being tested. Less than and greater than signs you saw in the for loop, but you can use these as well in the while loops. This loop is indefinite because there isn't a set incrementer that will eventually hit the results. I imagine you could see how this could be used as a simple method of password protection before proceeding with your program. Thank you very much for coming to this introduction. If there's anything that you'd like to see more or less of in future classes, if you'd like us to explore this topic in more depth or in more details on certain small parts of it, we'd love to hear about it and be happy to add more classes. Have a great rest of your day.